Steel, the nation builder, plays the leading role in the development of America.
A US government film from 1946, making clear how steel has long been seen as key to the prosperity of big industrial nations.
Steel, the bone and sinew of our industrial world. Steel, the tool.
Today, though, steel is viewed less glowingly by many as another example of a heavy industry which needs to clean up its act.
9% of global emissions come from the steel sector. In fact, steel is the second largest emitter after cement. So there is a real pressure externally to decarbonise. Lots of governments around the world have committed to zero carbon by 2050, and it looks as though those targets are going to come closer as well.
Chris MacDonald is a former research and development manager for one of the world's biggest producers, Tata Steel. He now leads an independent research and innovation centre called the Materials Processing Institute in the UK. When I spoke to him, we began at ground level. How is steel made?
We start with iron ore, which we mine in places like Brazil and Australia. And the iron ore contains iron, but it also contains oxygen. And we need to get the oxygen out in order to purify it. And to do that, we heat it up to very high temperatures, to 1,400 degrees centigrade. And we do that using coal, and that's where the carbon dioxide emissions come from. The output of that process in the blast furnace is a very hot liquid iron. To make it into steel, we combine it with some other metals. We also put a little bit of carbon in it as well. That helps with the strength. And then we let that go hard, and we can shape it and form it. And that's what steel is.
Carbon, in the form of a special kind of coal known as coke, is a fundamental part of the very chemistry of how steel is made, a process for turning rock into metal discovered in the Iron Age. Now, though, work is underway in laboratories across the world to find new ways to reduce steel's carbon footprint in the 21st century.
And we can see that in this furnace here, there's this transformation happening right in front of my very eyes. We've got all this fantastic...
I'm Professor Veena Sahajwalla, and my absolute passion in life is recycling waste materials.
Professor Sahajwalla is a materials scientist at the University of New South Wales in Sydney, Australia. Like much of the current research into greener steel, her laboratory work focuses on using hydrogen instead of coal to spark the all-important chemical reactions in the process. She's found you can swap coal with old shredded tyres and even used coffee grounds.
We're attempting to actually show that the future may look quite different. Some of the materials that we all have in our everyday lives, we may not realise, like tyres, are actually rich in hydrogen.
And it's not just old rubber tyres, I understand. It's coffee grounds, waste grounds from our cups of coffee that we drink every day that you can also use.
Absolutely. We're really looking at all kinds of materials that, of course, ultimately, in an ideal world, should come all from waste. That there's a lot of waste residue that we all have in our coffee machines. And that coffee is now another rich source of elements that we can utilise.
So in practical terms, what do? You simply mix up old tyres and coffee grounds into a furnace and burn them instead of coal? Is it that simple?
Oh, no, it's not that simple. Of course not, Mike. We're not actually burning these materials. We are injecting these materials inside a liquid. Imagine a frothy cappuccino coffee. We've talked about coffee. Picture that layer into which our materials are being injected. And the heavy steel that is then formed, the liquid metal, drips down to the bottom of the furnace. That's what's happening inside a steelmaking furnace, except it's a lot hotter than your morning coffee.
Steel companies in Australia, South Korea and Europe are already trialling Professor Sahajwalla's method. That, though, will be the biggest challenge of all, transferring laboratory concepts to the real world, making greener steel at scale and at a cost which won't put producers or their customers out of business.
A future without steel is not an alternative. That's why change is our only alternative.
The promotional video from a Swedish steelmaker called SSAB, a business with ambitions to become the world's first large-scale green steel producer. SSAB is trialling the use of hydrogen to turn iron ore into steel at a pilot plant in northern Sweden. The hydrogen itself will be generated using renewable electricity. The company says this will result in virtually no carbon dioxide emissions, with water vapour the only byproduct. Eva Pettersson is SSAB's Executive Vice President for Research and Development.
It hasn't been done before. We're looking at a new process, never before done in industrial scale, replace the carbon with 100% hydrogen. And instead of carbon dioxide, produce water, H2O. We know that it works in lab scale, but we need to scale it up to an industrial scale.
What about the costs, though? Will steel produced from this hydrogen-based route be more expensive? And if so, how much more expensive?
We have had an estimate of about 20 to 30%, but it's very difficult to say where this number will end up in the future. But we don't see that as a showstopper at all. We think this needs to be done.
So you think your customers would be prepared to pay more?
Yes, we can put a price on our commitment to climate change, I think.
How confident can you be that greener steel can be produced in the sort of quantities that the world demands? I mean, some people might say it's all very well for you. You're not the largest steel producer in the world. I think you're around number 40 odd in the global league table. How easy will it be for the whole industry across the world to turn out products with a smaller carbon footprint?
Other players bigger than us, they are also talking about the goal not to emit carbon dioxide in the first place, to actually hit the root cause, to find other ways of doing this. But it's challenging, and we've only just started.
From one of the world's smaller steelmakers to one of the very biggest now, ArcelorMittal has plants in 18 different countries and produces 90 million tonnes each year. I've been speaking to ArcelorMittal's head of sustainable development, Alan Knight. He believes it may not be practical for big producers to stop emitting carbon dioxide. Finding ways to capture carbon instead, so it doesn't escape from the steelworks into the atmosphere, he says could be a better way forward.
That route is, according to our calculations, coming in at a lower cost. If it doesn't go in the sky, what's the problem? And so if we can decarbonise at a lower cost, surely we owe it to ourselves and our customers to pursue that.
So you're keen for carbon capture to be a part of this future. Is, though, the technology really there for that to happen effectively at the moment?
Yes. And we're piloting it. But you could ask the same question of hydrogen. Is that technology really there? The honest answer is all of us are at the pilot testing stage. Work in progress, still more to be done.
I've heard one estimate that the cost of greening the global steel industry will be $1.4 trillion. So are you going to have to ask your customers to stump up more? The world's construction companies, the automakers, the plane makers, are they going to have to brace to pay more for one of their most important raw materials with this drive to go greener?
In a nutshell, yes. We are reinvesting in our business and we're putting in new processes to deliver this low carbon obligation the world has now set itself. That will come at a price.
I was talking there to Alan Knight, and he's head of sustainable development at the steel company ArcelorMittal. That report was produced by Sarah Parry. You're listening to World Business Report from the BBC World Service.